our element. So negative shear, it just gone in the different direction from positive shear. Okay, and this is our how our element will be distorted, okay, or deformation. So I'm drawing the deformation now. So you can see now the difference between the deformation between positive shear, right? And also you can see the difference between negative shear, right? So this is my deformation pattern. Okay, so you can see that the deformation pattern now. So I'm going to, as usual, we are going to label this point X. Okay, we're going to label this our point X. This will be our point Y. Again, this is our point X. Okay, X. And over here, this is our point Y. So now we're going to translate this onto Mohr circle. Okay, and I want you to see this. Okay, first, before I start drawing the Mohr circle, both positive and negative shear are as good or as bad. Okay, there's no like positive shear is better than negative shear. Okay, so both are as bad. Unlike normal stress, compression to some material is better than tension. For example, concrete, okay, brittle material, okay, brittle material, they are better off in compression than tensile, okay. Well, shear, okay, both positive shear are as good, okay, or are as bad. For example, if you design carbon fiber, okay, structure is carbon fiber, both positive, negative shear are both bad. Okay, if you design, if you have ductile material, does not matter. Positive shear, negative shear does not matter. It's fine. Okay, right. So let's look at the Mohr circle now. Okay, so I'm going to draw Mohr circle now. Okay, I'm going to draw Mohr circle now. So on Mohr circle, this is my axis, axis, normal stress, shearing stress. Okay, so that's our axis over there. So so this is your normal stress. Now, remember the shear, what do we say? Shear we draw over here clockwise and down here anti-clockwise. What is this clockwise or anti-clockwise? Or anti-clockwise is basically the rotation of the element. Okay, right? Okay, so what do I mean by that? So let's look at point X then. Okay, so but let's see where's the shear now. Okay, so if you look at the Mohr circle, right? This is our shearing stress. Our shearing stress line, right? One on top, one at the bottom. So you will realize, you will say, Eugene, if positive shear, right, isn't the shearing stress just going to be positive, right? So my answer is no. You still have to draw both positive and negative. This is because the location of the element point X to Mohr circle does not depend on what? Does not depend on whether the shear is positive or negative. It is dependent on the rotation of the element where the shear stress is inducing. Let me elaborate. Okay, so now let's look at over here. We look at point X now, right? Where I'm highlighting. And the stress at point X is going upwards. Okay. Now, if you put your finger, or if we put a pin in the center, means the element is able to rotate. Yes or no? Right? So when that's the case, this arrow over here that I've just underlined will make the element, right, rotate in a what? In a anti-clockwise direction. Yes or no? That is rotating in an anti-clockwise direction. So you go to Mohr circle now, right? The bottom part, this is your point X, because the element is rotating in the what? Anti-clockwise direction, right? The element is rotating in a anti-clockwise direction. You can see this arrow down here. It is what? Anti-clockwise. So let me do it again. Okay, let's look at point Y. Let's look at point Y now. Okay, which I'm highlighting in yellow. At point Y, the shear stress is going towards the right. Yes or no? So if you put it, if we pin this box, when it's pinned means the element can rotate. Yes or no? Right? The yellow arrow that I've just highlighted will induce a what? Will induce a clockwise rotation. Okay. So when that is the case, over here, this will be your point Y because the element is rotating clockwise. So from here, you can construct your Mohr circle. Okay, you can construct your Mohr circle. Okay. So for this case, for this element that we see down here, that I've just drawn, right? For both case, the normal stress are both equal to what? 0. Okay, so normal stress X is equal to 0. Normal stress Y is also equal to 0. Okay. Now, let's look at negative shear. Okay, let's look at negative shear now. So I'm going to draw my axis. Right, I'm going to draw my axis. This is normal stress. And then the vertical one. That is our shearing stress. Element rotate clockwise and element rotate anti-clockwise. No doubt the shear is known as negative shear. We will still draw the shear at the positive and the shear at the negative. Okay. So now let's look at point X now. Let's look at point X. Okay. And point X, based on the arrow just highlighted, right? And if we fix at the center, we pin at the center, means the element can rotate, right? X will generate a what? A rotation. The arrow will generate a rotation in this direction. So it is going in a clockwise direction. So for this case now, point X is at the top. Okay, point X is at the top. Then on the other side, okay, now we're going to do Y, right? On Y, okay, so when you see on Y, this arrow over here that I just highlight in blue will generate an element rotation in a anti-clockwise direction. Okay, so this is over here. This is your point Y. All right, so from here, you can easily draw the Mohr circle. So a very interesting thing you see now is it flips over, right? So now you don't see the effect. Okay, you say, Eugene, so what if it flips? Okay, so what if it flips? Okay, so later on, I'm going to show you, so what if it flips? Okay, but it's important to know where is X and where is what? Y. Because if you got it wrong, the rotation will be wrong and you can get a lot of other things wrong. Okay, right. So another thing I want you to observe is this. Okay, I want you to observe point X to point Y. So let's look at the negative shear. Okay, so from point X to point Y, if we were to rotate from the center of our circle O, right? Point X to point Y is how many degrees down here? Can anyone tell me how many degrees is that rotation from the center of the circle? Anyone? This is to make sure no one is sleeping. Anyone? How many degrees is that?
180.
180 degrees. Now, if you look at the element from point X to point Y, how many degrees?
90.
90 degrees. Okay. So this says something. What did it say? If the on the element, right, the angle, element angle is theta, right, comma, Mohr circle, okay, Mohr circle okay, angle is 2 theta. You just saw that for yourself. Okay, this is the way I'm showing it. Okay, I can go through 45 minutes of transformation equation to show it, but I don't want to waste your time. Okay, so we can see that on the element, right? If you look at the element, the angle is theta, right? On Mohr circle, the angle is what? 2 theta. So this is another characteristic of Mohr circle. Okay, right. Next, we are going to look at, before we go any further, any questions so far? Anyone? So be careful, okay? Positive shear and negative shear has nothing to do with the magnitude. I'll write this down. I think this is important. So positive shear, the position, okay, the position of point X and Y on Mohr circle is dependent on the rotation of the element induced by the shearing stress. Okay. Yeah, I put down here nothing to do with positive or negative. Okay. Okay. I want you to make sure you understand that. Okay. You don't say, hey, Eugene, you're positive, so why not all positive? No, it all dependent on the rotation of the element, like from what I've just shown. Okay. So before we go into more circle stuff, I'm going to describe to you the rules of the circle. Okay, we're going to look at the rules of the circle. So I'm going to talk to you guys, okay, on the rules of a circle. Hold on, don't worry, I'll move the page. Okay, so rules of a circle. Okay. So we are going to look at the rules of the circle. Okay, so those of you, all of us are at home now. If you can manage to find a compass, I will encourage you to do so. So we're going to draw a circle. Okay, we're going to draw a circle. So you use a compass to sketch a circle out. Okay, so this is my circle. Okay, so 2, 4, 6, 8, 10. Okay, so 2, 2, 4, 6, 8, 10. Okay, that's my circle. All right. So the center of the circle is over here, and I'm going to call this my point O. Now this is just a circle. Okay, this is not a Mohr circle. This is just a circle that we're looking at rules of circle. Then the next thing I'll do is I'll draw a straight line from one end of the circle to the other end, intersecting O, center of the circle. Okay. All right. Okay. Then I'm going to pick a point. You can pick any point. I'm going to pick a point. And the point I'm going to pick is over there. Right. So one end of the intersection I call point A. Where it cuts to the other side, I'll call my point B. And the point I just picked, I'll call it point C. Okay, so those are the points. So the next thing that I would like to do is I would like to join. Okay, I like to join point A to point C, and then from point C to point B.